All right, so we will sketch this polynomial, and general form means that it's not factorized. We can't move it around with the table of transformations like the previous ones we've done. So we need to actually find all our features, the same features we had. So let's have a look. So our features of the polynomial will be x-intercepts, y-intercept, special feature, which we're not going to find, but I'm considering it because I always have some sort of special feature, and usually we can find it. We just can't do this in year 11 yet, finding the turning points. And shape. So I'm going to say, well, special feature, I'm considering there's a special feature, but I'm not finding it for the sake of year 11 methods. Done. Let's have a look. The shape. This is really easy because the shape is going to be a positive, because out the front, look how it's y equals positive x cubed minus 3x minus 2. So it's going to be positive, and if you forget that the positive looks like an n, you can probably work that out once you put the y-intercept and the x-intercepts on. So it's good if you can remember that, but if not, you can apply the intercepts and see that. That's that. So we're left with the y-intercepts and the x, or the y-intercept and the x-intercepts, and the y-intercept is easiest in this case. So I'm going to do the y-intercept first, because you see, if I've got the y-intercept, the shape, and, well, not the special features because I don't find it, but it means that I'm able to get maybe 3 out of 4 marks, or maybe even 2 out of 4, because the x-intercepts, you probably get more than 1 mark for that. So let's see, the y-intercept is where x equals 0, just like we've been doing all along. So minus 3x. So there's our equation, and I'm just going to sub a 0 in. You might be able to see that it's very easy to see the y-intercept because, well, look at that. You could see it just from the equation. You can see that when you sub 0 in, you're going to x, you're going to get a -2 for y. So you don't even need to show that working out. You want to just state that the y-intercept is when x equals 0, and then you can just see the y-intercept. So there's our y-intercept, y equals -2. It's ready to go on the graph. And the only leftover thing to do, which is actually pretty hard, is the x-intercept. So what I'm going to do, I'm going to draw what I've already got, because if I don't find the x-intercepts, if I can't do that, or I get stuck or run out of time, I'm going to be at least getting probably half my marks just from doing, the shape and the y-intercept there. So -2, or at least some marks, maybe not half because the x-intercepts are quite involved. -2, and I know it's going to be this shape. So maybe something like that. So we'll see what the intercepts are for x. It might not look like that. It might look like this. I don't know. We'll find out. Let's do that now. So x-intercepts, y equals 0. So we have x cubed minus 3x minus 2 equals 0. And this is where we're going to need to do long division of polynomials. So this is why we do long division of polynomials. So we can find our x-intercepts, we can factorize our polynomial and solve for x-intercepts. So the first step, and you might well remember from last year, the first step is to find, oh, why is my thing lagging? The first factor, random factor. I don't know why my pen's being a bit weird. All right, find the first random factor. So it's not really random, but the point is you need to just sub in values. So what we know is if we sub in a value and it equals 0, then it has to be a factor, because 0 remainders for a factor. So let's see, I'm going to say, let's sub in x equals 1. So let's try x minus 1. Let's see if that's a factor. So what do? I say x minus 1 equals 0. That means x equals positive 1. So I'm going to sub that in. Let's see if that equals 0. 1 cubed minus 3 times 1 minus 2. Let's see, 1 cubed is 1, 1 minus 3 is negative 2, and negative 2 minus 2 is negative 4. So that won't do, that's